Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. It is 5.5, Rational Functions, Transforming Rational Functions. What this means is we are going to start looking at the graphs of our fractions. So a rational function is a function whose rule can be written as a ratio of two polynomials. Basically what that means is a fraction. Okay? The parent rational function is f of x is equal to 1 over x. We need to fill in the chart for the parent function and graph the function. To fill in our chart, we always start at 0, okay? So if I put 0 in for x, so f of 0, I'm just replacing all my x's with 0, 1 over 0. If you type that into your calculator, what you're going to find out is that 1 over 0 is not allowed. It is not true. So our f of x is actually going to be nothing. I use a squiggly line. Use something that signifies to you that there is nothing there. We'll explain what that means here in 1 second. Okay? Now, we're going to move to the right. So f of 1 is equal to 1 over 1. Well, 1 over 1 is 1. So our f of x is 1. Then f of 2 will be 1 over 2, which equals 1/2. Now, before we move on, what I want to do is go ahead and graph those two numbers that we just found. So for x is 1, that is x is 1. We're going to go up to number 1. Okay? And for x is 2, here is x is 2. We go up to 1/2. And those are our first 2 points. All right? Now that we have taken our 2 points to the right, we also need to take 2 points to the left. So I'm going to put -1 in for x. So 1 over -1 will equal -1. So when f of x is -1, when x is -1, my f of x or my y is also -1. And then for f of -2, so I'm looking right here, my x is -2. I will put -2 in my denominator in for x, which is -1/2. So I need to graph those 2 points as well. So for x being -1, I move over to the left 1, and I go down 1. What you're going to notice about all of these graphs is I will have one portion that is in one corner, and the other portion will be in the opposite corner. Okay? So when x is -2, it's right here, I'm going to go down to 1/2. Okay. Now, there are things called asymptotes. Okay? And asymptotes always start at the zeros. So there'll be an asymptote here. There'll be an asymptote here. What that means is I actually have a hole in my graph that I can never touch or cross. So what's going to happen is for this bottom left portion of my graph, I'm going to get really close to the x-axis and then finish really close to the y-axis. Same thing with the top right portion. I get really close to my y-axis, and I finish really close to my x-axis. But notice, I never touched the x or the y-axis. So that is the graph of our parent function. Our parent function is what every movement is going to be based off of. So if you can imagine that in your head every single time you're doing one of these problems, and then just imagine taking this 0, 0 point and moving it where it tells us to, then you'll have a good idea of how we're going to move this graph. Okay? So using f of x equals 1 over x as a guide, or our parent function that we just talked about. This is our formula right here. Okay? This is very, very similar to the formula. You don't have to write this down, but just remember this. This is really, really similar to our formula that we did in the first semester, where I had that. Where if you remember, everything that was inside the parentheses, we did the opposite. Everything that was outside the parentheses, we followed it. Okay, so that's going to happen again here. Everything that is going to be underneath the fraction sign, we're going to go opposite directions. It's a right to left movement underneath, and it's an up and down movement for our k, or the outside, away from our fraction. If it's underneath my fraction in my denominator, then I'm going to go opposite. If it's outside where my k is, then I'm going to follow what it tells me to do. So if h is less than 0, I'm going to end up moving it left. So if h is less than 0, then we will move the graph that many units to the left. Here's an example of what it would look like if our h is less than 0. We'd have f of x is equal to 1 over x plus 2. So in that case, I would actually take my graph and move it 2 units to the left. Okay? And if h is greater than 0, then we will move the graph that many units to the right. So an example of what it would be if my h is greater than 0 would be f of x is equal to 1 over x minus 2. In this case, again, I'm going to do the opposite of what my denominator tells me. My denominator is telling me it is negative 2, so I'm going to move to the right, which is positive. So for the first two, for my h, the h tells me to move left and right. Okay? Now for the second portion, which is going to talk about our k. Using f of x equals 1 over x as a guide, if k is less than 0, then we will move the graph that many units down. An example of this would be f of x is equal to 1 over x minus, it's less than 0, minus 3. In this situation, I'm going to take my graph and move it down 3 places. And if k is greater than 0, we will move the graph that many units up. So an example of k being greater than 0 would be 1 over x plus 3, which tells me to move up 3 units. This tells me to move down 3 units. This first, back up here, maybe this will help you out a little bit. This will tell me to move left 2 units, and this will tell me to move right 2 units. Okay? A vertical asymptote is a vertical line that starts at x equals 0. So x equals 0 in the parent function is, I'm going to use blue, is this vertical line. It's that vertical line. And it is going to move, as the h moves. So the only direction that the vertical asymptote can move is right and left. All right? Now the horizontal asymptote is a horizontal line that starts at f of x equals 0 in the parent function. That's going to be my red line. That's right here. And it is going to move as the k moves. So that means that it can only move up and down. All right. Now I understand that those are some abstract thoughts, some abstract ideas. So what we're going to do now is go ahead and look at some problems. I'm hoping after you guys see some problems, you will realize that this is not overly difficult. Okay. So using the graph of f of x equals 1 as a guide, describe the transformation, identify the asymptotes, identify the domain and range, and graph each function. Let's take it piece by piece. So the first thing we're going to do is describe the transformation. So this is where if I have a number underneath the fraction, or if I have a number outside, it tells me which direction to move. So anything under the fraction will move right or left. And remember, if it's under the fraction, I'm actually going to go opposite of what it tells me. So in this case, I have a negative, which would be left movement, correct? But since it's under the fraction sign, I need to move it to the right. So it'll be a horizontal translation right 3. And that came from this x minus 3. All right? So since I had a horizontal translation right, there's no number on the outside. That tells me that I do not have a vertical translation. So I don't need to write anything down about a vertical translation. So we have taken care of our describe the transformation. Next, we need to identify the asymptotes. Okay? So the vertical asymptote, we're just going to use SY or ASY as our abbreviation for asymptote. Our vertical asymptote starts at x equals 0. Well, if I move my graph 3 places to the right, that's my new center, okay? Then my x has moved to x equals 3. So my vertical asymptote will now be x equals 3. My horizontal asymptote would only change if I have a vertical movement. So it starts at y equals 0. Now remember that the y's are our horizontal lines. These are all y's, okay? And all of my x's are our vertical lines. That's why I moved to x equals 3, all right? So since I have not moved off of my y-axis, my horizontal asymptote would be y equals 0. So whatever you need to do to remember that the vertical asymptote is my x and the horizontal asymptote is my y, you need to find a way to get that stuck in your head so that you can remember that. So now what I'm going to do is I'm going to go ahead and plot my vertical asymptote and my horizontal asymptote. I'm going to use red for the vertical asymptote. It's at all the places that x would equal 3. I'm going to use blue for my horizontal asymptote, and it's at all the places that y would equal 0. Now, remember from the top of the paper where we had a graph that was in the top right and a graph that was in the bottom left. We're going to have the same situation here. And using those asymptotes, I now know that my top left corner is going to be, my top left corner is going to be this section up here, and my bottom left, top right corner, my bottom left corner is going to be this section over here, okay? But it's those sections around the asymptotes. Now, I normally start with 0 in the middle, but since I moved to the right 3 places, my middle is now going to change from 0, I add 3 because I moved to the right, so that's going to be 3 now. So my horizontal asymptote is actually going to end up as my center. All right. Now I'm always just going to add 1 as I go to the right, so this would be 4. Add 1, this would be 5. Then I'm going to subtract 1 going to the left, so this is 2. Subtract 1, this is 1. Now, just like my parent function, my center is not going to have an f of x value. So my center is going to be blank for f of x. All right? So from here, what I need to do is I'm going to put 4. I'm going to put this 4 in for my x value. So to solve this, I have f of x, or f of 4, equals 1 over 4 minus 3. Well, 1 over 4 minus 3 is 1 over 1, which is in fact 1. Okay? What I also want you to realize is the first number to the right will be 1 unit higher than my horizontal asymptote, so my blue dashed line. So I'm going to go to 4, 1, 2, 3, 4, up 1, and I have my first point. Now my 5, if I put 5 in for x, f of 5 equals 1 over 5 minus 3, which is 1 over 2. So this is going to be 1 over 2 or 0.5, either way. Okay? So I go to 5, 1, 2, 3, 4, 5, up a half, and now I have my top right corner. Remember, I want to be as close as I can to the asymptote, then I'm going to bend it and get as close as I can to the next asymptote. So I'm done with the entire right-hand side of my graph. Now I need to move to the left-hand side of my graph. So I'm going to have f of 2 is equal to 1 over 2 minus 3, which is 1 over negative 1. 1 divided by negative 1 will be negative 1. So I go to 2, 1, 2, go down to negative 1, and there I am. So now if I put 1 in for x, so f of 1 equals 1 over 1 minus 3, which is 1 over negative 2, which is equal to negative 1 half. So I go to 1, down to 1 half, And again, really close to my asymptotes, but never touching or crossing them. Now, the last piece after I graph is I need to identify the domain and the range. So my domain is going to be all of the x values that are possible. So this is a possible number, this is a possible number, yes, 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 yes. Now when I get to x equals 3, remember that that vertical dashed line means there is a hole in my graph. But every other number on my graph going on in both directions, all the way to infinity, can be part of my answer. That's what this arrow here means. And that's what this arrow here means. It means all those x values are part of my answer except for that one at x equals 0. So it's going to be all real except 3. Okay? Now my range is going to be all the numbers that are y's. So all of these are going to be part of my graph except for that dashed blue line, which is at 0. So all the rest of these would be allowed. And you can see that based off of this down arrow and this up arrow. Okay? I'm sorry, I did not put -1/2 here. So that means I have every y value possible in both directions all the way to infinity except for y equaling 0. So it's all real except 0. And your domain is always your x values. Your range is always your y values. Your vertical asymptote works with my domain. The horizontal asymptote works with my range. Every single time. So whatever your vertical asymptote is, that will tell you what your domain, what the only exception from your domain will be. Whatever your horizontal asymptote is, that will tell you your only exception on your range. Let's move on to the back. So I have f of x equals 1 over x minus 2. So here I do not have a number underneath the fraction bar. So that means I will not move right or left. I have a number that's outside, so I'm going to move up or down. Well, think about if it's outside, I follow it. So -2 tells me I will move down. So the only movement I have is down, which is a vertical movement. So I have a vertical translation down 2. The next piece of information I need to find is my vertical asymptote. Well, my vertical asymptote, actually, you know what? I want to change this up a little bit. Whenever I have a vertical translation, that is going to help me figure out where my horizontal asymptote will move to. Okay? So vertical translation and horizontal asymptote work together. So it's the horizontal asymptote starts at y equals 0. If I move down 2, that means that my horizontal asymptote has now moved to y equals -2. So it started at 0, now it's at -2, which means that I have a horizontal asymptote at -2. My vertical asymptote, if you look back at this problem, my vertical asymptote worked with my horizontal translation. So my horizontal translation told me to go right 3, so my x went from 0 to +3. Okay? So my vertical asymptote, which works with my x's, has not moved from x equals 0. So what I'm going to do is I'm going to label everything that works together as x or y. So the vertical translation works with my y. The horizontal asymptote works with my y. The vertical asymptote works with my x. Okay? So now I need to go ahead and get my vertical asymptote drawn, which is going to be right on the y-axis. Now from here, I need to go ahead and fill in my table. The only way that my center changes from 0 is if I move right or left. In this problem, I did not. I went down, so this goes back to 0. Remember, I'm going to add 1, which means this is 1. Add 1, this is 2. Subtract 1, this is negative 1. Subtract 1, this is negative 2. And again, every single time I have a problem like this center, the bottom, right where my center is, my f of x value is going to be blank because that is this line. It is this vertical dashed line, okay? So if I put 1 in for x, I'm going to take 1, which is right here, and plug it in for this x. So f of 1 will equal 1 over 1 minus 2. Well, 1 over 1 is 1, minus 2 is negative 1. So when I'm at 1, I go from 0, here's 1, I go down 1. Then if I put 2 in for x, f of 2 equals 1 over 2 minus 2. Well, 1 over 2 is 1/2. Minus 2 would get me negative 1.5. So I go to 2, here's 1, there's 2, go down 1/2. Oh, 1 and 1/2, I'm sorry, 1.5. So here's 1, here's 2, go down to 1.5. I want to make my graph as close as I can to those dashed lines without touching or crossing. And I have my top portion of my graph. Now I need to work with the left side, on the left side of my center or my 0. So f of negative 1 will equal, I'm putting negative 1 in for x, so 1 over negative 1 minus 2. 1 over negative 1 is negative 1, minus 2 gets me negative 3. So if I go to negative 1, it's here. Negative 3 is 1, 2, 3. Now if I put negative 2 in for x, f of negative 2, it would get me 1 over negative 2 minus 2. So negative 1/2 minus 2 would get me negative 2.5. So negative 1, negative 2, negative 1, negative 2, and 1/2. Get as close as I can to these dotted lines without touching or crossing. The final thing I need is my domain and range. Remember, my domain is going to work with my x, so my vertical asymptote. So my domain is all real except 0. My range is going to work with my y value, so it's all real except, we'll find a number that works with my y value. It would be our horizontal asymptote, so negative 2. And I am done. All right. On to problem 3. Okay. So I have a number that's underneath my fraction bar. That means it's going to move either right or left. If it's underneath the fraction bar, I go opposite. Well, since it's positive, I'm going to move to the left. So I have a horizontal translation left 7. The horizontal translation works with my x. Now, horizontal translation works with my vertical asymptote. Okay? So that's also going to work with my x. Since it went left 7, my vertical asymptote is going to be at x equals negative 7. So go to negative 7. 1, 2, 3, 4, 5, 6, 7. Make a vertical dashed line. I need my other asymptote, which is my horizontal asymptote. That started at y equals 0. Since I did not move up or down, it's going to stay at y equals 0. That works with my y. So I need to go ahead and make a dashed line at all the points that y would equal 0. Okay. Now I can go ahead and fill out my graph. Remember that x always starts at 0. However, I had a horizontal translation. This horizontal translation of left 7 would tell me to take 0 minus 7. So negative 7 goes in the center. I never have a point underneath. So I'm going to add 1 from negative 7, which is negative 6. Add 1 from negative 6, it'll get me negative 5. I'll subtract 1 from negative 7, that's negative 8. Subtract 1 from negative 8, that's negative 9. So I need to go ahead and plug these in. So if I plug negative 6 in for my x, I end up with f of negative 6 is equal to 1 over negative 6 plus 7, which is equal to 1 over 1, which is in fact 1. If I plug negative 5 in for my x, it would be 1 over negative 5 plus 7, which is 1 over negative 2, which is negative 1 half. So if I go ahead and plot these points, go to negative 6, 1, 2, 3, 4, 5, 6. I'm sorry, that's not negative 2. That should be positive 2. I apologize. Which means that my 1 half will not be negative. It'll be positive. So I go to 1, 2, 3, 4, 5, 6, up 1. Go to 5 and 1 half. Go ahead and plot my points and graph. Okay. Now I need to plug the negative 8 in for x. So f of negative 8 will equal 1 over negative 8 plus 7, which is 1 over negative 1, which would in fact be negative 1. So if I go to negative 8, that's 1 point past my vertical asymptote, and down to negative 1, I'm here. F of negative 9 is 1 over negative 9 plus 7, which equals 1 over negative 2. So then I go to negative 9, 1 half, negative 1 half, and plot my graph. Okay? The last things again are my domain and range. So my domain, which works with my x value, this x tells me that my x's are going to work with negative 7. It'll be all real except negative 7. My range works with the y's. It has not moved. Horizontal asymptote. So it's all real except 0. On to the last problem. Again, I don't have a number underneath my fraction bar. I have a number on the outside of my fraction bar. If it's outside of my fraction bar, that means I'm going to follow it, and it'll either go up or down. Well, since this is positive 3, I'm going to move up, which means I have a vertical translation up 3. The vertical translation works with my horizontal asymptote. Because the vertical works with my y, the horizontal works with my y. So my y has moved from 0 up 3, so it'll be at y equals 3. If I go to y equals 3, there's y equals 1, 2, and 3. I'm going to have a horizontal asymptote at 3. Now I need my vertical asymptote. Well, my vertical asymptote works with my x value. X starts at 0. Since I did not move left or right, it's going to stay at 0. Here is x equals 0. So I have a vertical dashed line at x equals 0. Since my x has not moved, my center will be 0. My f of x is just a squiggly. I'm going to add 1 moving to the right. I'm going to subtract 1 moving to the left. Now I need to plug in all of my x values back into the original problem. So f of 1 is equal to 1 over 1 plus 3, which is equal to 1 plus 3, which will be 4. Now I need to put 2 in for all my x's. So f of 2 is 1 over 2 plus 3, which is 3.5. Go ahead and plot my points. So my x is at 1, my y is at 1, 2, 3, 4. My x is at 2, my y is at 1, 2, 3 and a half. Graph my lines. There is a pattern to your table. If you'll notice, it's going to be 1 point higher than my horizontal asymptote every single time with this point, and a half point higher every time at this point. It's going to be 1 point lower at this point. So really, If I start at 3, then this should be 2. When I have negative 1 in for x, it should be 2. Let's see if it works. F times negative 1 equals 1 over negative 1 plus 3. That gives me negative 1 plus 3, which is positive 2. So it is 1 point below my horizontal asymptote. So next I'll put negative 2 in for x. So 1 over negative 2 plus 3. That will give me 2.5. So it should be a half a point below, and it is. I'll explain that better tomorrow or next time I see you guys. Then I go ahead and graph it. Notice that I've had the graphs in the opposite sectors every single time. Now I need my domain and range, so my domain works with my x values. This x value tells me I need to be at 0, so it's all real except 0. My range works with my y values. This y tells me that it should be at positive 3, so it's all real except 3. So that is the end of our video. Remember, the most important thing to remember here is if I have a number in my denominator, it will move my graph left or right, and I will not follow the number. So if it's positive, I'm going to move left. If it's negative, I'm going to move right. And if it's outside of my fraction, that will move me up or down, and I will follow my number with that. If you have any questions over this stuff, please make sure you come in and see me. Otherwise, thank you very much for watching the video, and have a great day.